Today we will discuss in Econometry Volume 14, that is Stationarity and Unit Root Testing, that is ADF PP test. Myself, Dr. Ajay Bhatia from Institute of Economics and Management Studies. Today we will discuss about the stationarity in the model. Students, we have covered volume 13, 1 to 13. So please go and see the volume 1 to 13 for better understanding of econometrics. Now the question is, what is stationarity? To understand the concept of stationarity, we can say that a time series is stationary if it has a statistical property such as mean, variance, and autocorrelation are constant over time. Means variance, autocorrelation are constant over time. Then we can say that it is a stationarity model. So now again a question arises, why stationary is important? We have discussed previous models like AR and MA model. So most econometrics model like AR, MA and AR-MA model requires series to be stationary, as non-stationary series can produce spurious regression results. So it is very important to understand this topic. Now we will discuss the type of stationarity. How many type of stationarity are there? First, strict stationarity. It means the entire distribution does not change over time. Here distribution is remain same over time. Then there is a weak stationarity, or we can say covariant stationarity. Here only the first two moments, that is mean and variance, are constant, and autocovariance depend only on the lag. In previous videos I have told you about the lag. It is a time period basically. In actual practice, we work with weak stationarity model only. Now the characteristics of non-stationarity series, that is time varying mean or trend. Here changing variance over the time. It means autocorrelation that decay very slowly. And there is a second thing, is the presence of a unit root. So student, what is a unit root? To understand unit root, we can take AR as a process, autoregressive process. Here equation is yt equal to gamma yt minus 1 plus ut. If gamma value is equal to 1, then we can say that series has a unit root and it is a non-stationary. If positive gamma is less than 1, the series is a stationary series. Unit root test. There are different tests for doing unit root. Most important is a Dickey-Fuller test asked in the examination, competition examination. Here we test, in Dickey-Fuller test, we test H0 equal to gamma equal to 1, that is unit root is non-stationary, and HA is our gamma is greater than 1 is a stationary model. So we can rewrite this above equation as change in yt equal to alpha plus yt minus 1 plus ut, and test HO at y equal to 0. Dickey-Fuller test assume that there is a no correlation in the error term, that is ut, means there is a no auto correlation in the error term. Second is test is Augmented Dickey-Fuller test. This is called ADF test. To correct the autocorrelation, we used lagged differences. Here we use lag differences, that is change in yt equal to alpha plus yt minus 1 plus summation w change in yt minus 1 plus ut. If value of y equal to 0, we can say unit root exists and model is non-stationary. If y is greater than 0, then we can say in this model it is a stationary. So if you understand the uses of a ADF test, we can say that statistics with compare with a critical value. Now we'll test statistics is compared with the critical value. Third test is again important test is a Phillips-Perron test. We can say it is also called PP test. PP test also tests unit roots, but correct for serial correlation and heterodicity without adding the lag item like ADF. Here we don't add the lag terms like in ADF. It is used in Newey-West standard errors to adjust the DF test statistics. Now we will discuss the trend stationarity versus difference stationarity. So what is a trend stationarity? So series becomes stationarity after removing the deterministic trend. When we remove the deterministic trend, it will be a stationary. The differences stationary series become stationary only after differencing. When we do differencing in mathematical part, then model become a stationary model. Students, we can take the example of ADF test. Suppose you have a time series of GDP, and after running an ADF test, we get result of test statistics as say minus 1.89, at 5% critical level value is minus 2.95. Since minus 1.89 is greater than minus 2.95, we fail to reject our hypothesis. It means GDP series has a unit root. That is, this model is a non-stationarity model. So in the end, we can conclude that stationary is a very important for time series analysis. And for this, the ADF and PP test help to determine whether series has a unit root or not. So differencing or detrending may be required before the model estimation. So students, I hope you have understand the concept. I again repeat that start from volume 1 to volume 14 to understand the full concept of econometrics. If you see the videos in the between any volume, you will not able to understand the concept. So thank you very much. Please subscribe and share our video. And again, if you have any problem, you can write in the comment box. Thank you very much.